Hey, everybody. Getting started in a second here. Everybody. One viewer, whoever you are. Let me know if the volume's okay, if you can hear me all right. Getting going in a second here. Boop-a-doo-doo-doo-doo-doo. Almost there. Ba-doo-ba-ba-boo. Okay. All right. Let's see. I've got another join. Oop, they already went away. Hey, down to one again. All right. I don't know if we're going to get anybody on a Friday. Don't know that I really care. Just feel like hanging out and doing some PCB work. I figure I might as well stream it. So, posted the few spots I can think to post. We'll see if anybody joins me. First time streaming from Colorado. Supposed to have reasonable internet here, so we'll see how that goes. Setup is mostly squared away here in the new house. We got folks joining. Hi, everybody. Let me know if you can hear me in the chat. There it is, in the chat over there. Let me know if you can hear me okay. I've got some music on the background. We're going to do some Topre PCB hacking here in a minute, which will hopefully be fun. I grabbed... Oh, give me 1 second. I'll be right back. I'm going to grab it. 1 sec. Okay. Anybody who knows me knows that I have an obsession with XIAO controllers. They are quite possibly the cutest controllers ever. Where'd it go? Fell out of the bag. There it is. So, for instance, I got one of these bad boys in just yesterday or the day before. Of course, it's in a static bag, so I can't handle it. Okay. Here's what we're talking about. XIAO controllers. They're tiny, they're cute, they're fun. But they have an interesting challenge. They have very low pin count in terms of usable I/O on them. But as I was thinking about this, I got this new one here today, yesterday. Happens to be a Renessa chip, the RA4 M1 from them. It's a Cortex M4 chip. Pretty beefy, has a very nice looking ADC on it, which got me thinking. I've been doing a lot of Topre designs recently. Speaking of which, this is what I'm typing on today. Topre wireless sheet for PCB. Got me thinking. This little XIAO has a nice ADC pin on it. If you know anything about Topre, you know you need good analog input for a Topre design. And my brain immediately got thinking, can I do a cheaper Topre design without needing to do as much expensive PCBA work if I did a XIAO design with it? And it got me going on the back of a napkin, got me thinking about pin counts and how many I would need for what. And I think I can make it work. And in particular, I think I can make it work while still being compatible with the sort of the standard baseline XIAO footprint, so that I don't need any extra spare pins like you find on like the XIAO BLE, the NRF 52840 one. Or these newer ones are really interesting. They have a bunch of small pads on the back, sort of spaced in between the actual solder, sort of two actual pin headers. Cool. And the last few designs have put them in the standard spots, which is kind of nice. But it's still, the XIAO BLE doesn't have it, for instance. And so until they do like a new revision, that still would sort of tie you to a certain XIAO. So I want to play with doing a Topre design using one of these little bad boys. And I have a few constraints here for what we're going to be working on. Okay. So one, I want to make sure that it will be an option with a XIAO BLE. And so we're going to get into what that takes as we go. I want it to also support wired. The RP2040 ADC has been pretty panned generally, but there's other options. There's the original XIAO, which is SANB21. Eventually I can use this for a wired build if I want to do the same thing. And so I want to be supporting wireless, which means I need to have battery pad, option. I want to support wired, and I want to not break out of just the generic XIAO footprint in doing so. So those are our constraints. So if we take a look at the XIAO, we're going to look at what we have to work with pins, talk a little about what pins we'll need, and we're going to dive in on doing some XIAO PCB design here. So taking a look here, boop, helps if I put it up here. Come on, Firefox. You can do it. All right. Switching over here. Taking a look at the XIAO here. We don't have a lot to work with, but I think we have just enough. So if you take a look at well, that's just a shot of it. Do they have the actual like pin numbering here? Yeah. Okay. So taking a look at this here. If we take a look at all the IO we've got pin D0 through D10. We've got 11 IO to work with. 10 plus spare. So I got 11 IO to work with. I'm going to be doing a Reviung take on this. So here's what those look like. For anybody who's not seen a Reviung, in particular, I want to do the Reviung 41 layout. I'd like to, if I can, I'm probably going to do the split space bar here. I'm not as much of a fan of the big 2U in the middle, only because these two are tucky, kind of hard to reach. So this is what we're talking about doing. Reviung 41. This one happens to be the standard Reviung 41 uses the Pro Micro, but we're not going to do that just for funsies. We're going to stick with a XIAO footprint, and so we'll use a XIAO footprint here. We want to use this general shape, and this is the layout that we're looking for. So if you take a look at this, you can see we've roughly got sort of 6 columns on each side, and then with a split space in the middle, we'll have 6 switches along the bottom. So if we think about this, we've really sort of got 7 sets of 6, if we want to think about it. I don't know that that's how we'll actually lay it out here, but that's what we're talking about. So with Topre designs, what we're probably going to end up with here is we'll have 4 strobe lines, which are going to be the lines that are going to pulse the voltage high. And so we'll have a strobe line basically for each row. And then we will have a couple muxes, which are going to pick which of our sampling, our read lines, to sample, so that's how we pick a certain location on this keyboard to sample and figure out the depth of the spring and blah, 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 figure out how far they push the button. So that's the plan here. And so here's what we're going to need. We're going to get gedited up so we can just talk about what we're talking about here in terms of what we'll need for pins here, right? So looking here, there's a few things. I don't know why this new gedit has this really lame highlight. I hate it. Can I change it? I don't want to waste time on it. Forget it. Close without saving. No, give me a terminal. Just give me Vim. So, talking about here, everybody. Can anybody send a message? Let me know if the audio, the volume's okay. Can you hear me? I keep scaring everybody away. I keep seeing the viewers jump and then viewers go away. Everybody's disappearing on me. Okay, so here's what we're talking about. We have to have 4 strobe lines. Those are the things that we're going to use as sort of outputs from our controller. We're going to pick one and we're going to spike it high, and then sample for parasitic, capacitance to see what the voltage is on one of our read lines. And so the way the read lines typically work is we use a mux to do that. And so the mux basically is going to use 3 input pins. You can hear me. Great. Welcome. Thanks for joining me. Doing some just high-level planning for the PCB before we sort of dive in here. So the 3 pins from the mux are going to let us pick one of 8 of the mux pins to route to our op amp. And Topre designs the op amp here basically is amplifying that voltage from our spike that we're going to cause, so that it's at a level that we can actually sample and read and get some reasonable values out of it. Otherwise, the spike is too low. We can't sample it with enough detail to get good readings out of it. So mux is going to hook up a certain one of our read lines from one of our columns to our op amp. It takes 3 pins to do that. Now, we're actually going to use 2 muxes, one for each side of this unibody split. And so we're going to have 2 enable pins, so that we can enable the mux on either one side or the other side. Yeah, there's our plan here. So we'll have 2 enable pins for one of the 2 muxes to be active at a given time hooked to our op amp. Okay. We need 1 pin for our ADC input, analog in. So we're going to need 1 pin that's just literally the muxes will be routed to the op amp. The op amp will be then be connected to our analog in input pin. That's going to actually be sampling our voltage spikes and seeing, how far the spring is pressed over the pads. So that's almost there. We're almost there. We got 4 strobe lines. That's going to be one sort of for each row here. We've got our 3 mux pins to pick the right line from the mux. 2 enable pins, 1 for each mux on each side, 1 analog in, and there's one more piece that we're going to need for this particular PCB, which is I want this to be wireless. And so for my one design that's here, the design on my wireless Zappy Bera, op amps are power hungry. They're basically greedy little buggers, and it comes to like a low power design. So we have 1 more pin, op amp enable. So I'm using an op amp for my Zappy design. We're going to pick the same op amp for this design we're going to do, that allows you to shut down or enable the op amp and basically take it from sucking like 200 UA down to like 5 or something super low. And so when we go into deep sleep, this is a ZMK feature, right, where we shut down the core and we stop scanning and do all that stuff, and we want to wake up from some other input. When we go into deep sleep, we don't want our op amp sucking 200 UA out of our battery the whole time. And so we're going to have an op amp enable pin that we will drive to a different state before we go into deep sleep. So that's going to help us save power when our keyboard is not in use at all, right? And so we take a look here. We got 4 plus 5, 9, 10. We got 11 pins. Lo and behold, we have 11 pins on our XIAO. We're good. We can make the design work. So that's the plan. Those are our pins. If we take a look at the XIAO footprint, there's a set of pins that are standard sort of analog pins in. This seems to claim that the original XIAO has analog inputs for all of the pins. But I don't want to rely on that for our design, because it could be that there are some of the other XIAO controllers that only have a subset of these pins that have analog in them. So that's my first task, is I want to double check which of these pins I really want to use that across the collection of possible XIAO controllers will work for my analog input here. So looking at the seed wiki here, They got a whole docks on all the various ones. That's the SAMD21. Pretty much any of those will work for an analog pin. I'm curious mostly about the NRF52840 because we want to make wireless. So if we take a look at the pins in use, why didn't you jump there? Let's try that again. There are docks. No, I don't want the on with. I just want the getting started page. Here we go. All right, so if we take a look here, the Arduino docks are usually pretty darn good. We can see, yeah, here we go. Okay, so on the NRF52840 version, the analog pins are only the first 6 pins on this left side. Cool. So for sure, even though the SAMD21 has all of them analog, this one, that pin 0 through 5 are analog pins for us. So we'll probably need to go with that one. But I want to double check this new controller I got because it seems to have be nice. And once I get it working, I want to make sure this will work as well. So we'll check the pin out docks on this one. Same deal. Arduino has been, the Seed Studio folks have been pretty good about being pretty consistent and with their designs that they've done on the sort of XIAO line. And so we can see, yay, yes, analog pins for 6 pins. So for sure, we're going to want to use one of those pins for our analog input for reading from our thing here. So we're there. Okay, we have a plan. So we're going to figure out the rest of our pin assignments as we go, because a lot of that will depend on sort of routing and what we want to do there. But for sure, we at least have a plan. We know we have the right number of pins. We know what those pins are going to do for the different pins, and we know what design we're doing. So next up, getting started here. I'm going to do a real hodgepodge of things here, and here's why. I don't want to have to totally start this from scratch. I'm going to open source this design anyway. This isn't going to be some commercial design. This is just one of those fun. I can open source it, and folks can play with Topre design stuff. So I'm going to base this on the actual Reviung 41 here as a starting point. So we're going to do that, but we're going to steal the schematic from one of my other designs. We're going to swap in a XIAO controller footprint instead for the controller portion. Steal a bunch of the footprints from a couple different of my projects and smash it all together and hopefully turn this into something by the time we're done here. So if you have any thoughts or questions while I'm going, hit me in the chat. Let me know. We're going to get started here in a second once I respond to one of my fans. Here in a second. Yeah. Okay. Somebody else responded, so they know what the deal is. So here we go. I'm going to cheat a little bit. Can I just download no, I can't. All right. So we're going to check out this repo, grab just the files we want. What is the license of the Reviung 41? Does he have a license listed? I always hate that when there's just no, maybe view all files. Is there a license file? Yes. Tell me what it is. MIT. Okay, so in theory, I don't have to open source this, but I like to open source fundamentals like this. So plan is open source. We're going to copy this repo, use the files, because a lot of stuff like the PCB outline and stuff like that, I don't want to muck with. I want to use those original things and not change that, except for the controller area probably. So we're going to clone this to start with. Get a new tab going here. Get into our Git folder. Grab this. And then while that's going here, what are we going to call this thing? I've been debating after I had this idea earlier today. I was like, what is this thing called? It's a Reviung, but it's EC. But it's got the XIAO controller. I really wanted to call it something really gross, like the Reviung. Reviung. Is that the worst idea ever? The Reviung? I think it might be. The Topre, also horrible. I hate naming. worst thing ever, right? Revpra. Top Reviung. I'm going with Top Reviung. I like it. That's the winner for now. Reviung. So we're going to be the Top Reviung. We're going to do this in a PCB directory. We're going to copy down those Reviung files. There's the Reviung 41 PCB. What's in here? Oh, there's different version folders. Grab the latest. We'll kill a few of those things. I'm sure there's probably some footprints and things that we'll need to also snag. But we'll start here. Skipping the directory, that's fine. Looking at this here, we don't want the zip file. I don't like the cache files being in here. That's annoying to me. I don't want your backup. Probably won't need that. I'm sure as soon as I XIAO, but I mean, because it's not always necessary built with the OEM Topre stemmer parts. Okay, although I technically agree with you, XIAO hurts me a little bit. Reviung. We're gonna stick with the naming for now. I hear you. I want to move on though. So we're here. So let's see. Okay, so it's gonna probably we're gonna leave that alone for now. We probably don't need the backup files. We will need the PCB. All right, we're going to go ahead and open this up. I am on a much newer version of KiCad, and so when I do this, I'm sure it's going to update everything for me. And then if we take a look at the schematic, obviously this is the schematic. The cache.lib was found. Abort. Yeah, we're going to rename this file. It tried to pick up file name automatically. Topre cache.lib. I swear I just put it there. Okay, so let's take a look. Probably no project specific libraries. No. So then why are you freaking out on me, KiCad? Honestly, I'm not as worried about the schematic here. Let's see if I can at least get the PCB to load, because the schematic I'm actually going to steal from a different project. Yeah, okay. Legacy, not supported zone, will convert it on a best ever basis. Great. Okay, so here is the original PCB. It's got a few things that we're going to be ditching on this. Obviously, the footprints are going to need to get swapped out when we do that. There looks to be a single RGB LED. We don't have the pins for that, so we're not doing that. We're going to ditch that. But this general size and shape, edge cuts, all of that, we're going to steal wholesale and make it work. So let's now drop in a different schematic that is based on a different design as a starting point, so we don't need to start from square one here. And then we'll go from there. So here's what we're going to do. I have another design of mine. That is called Mini Cap. That is a, yeah, that's probably closer in size. Yeah, okay. So if we take a look at this Mini Cap, I have a PCB in here, and we're going to steal all of the schematic files out of this and bring them over to our PCB over here, and we're going to use those for our starting schematic here. So if we take a look, we'll close this for now. I'm actually going to reopen that once I clean all of this up. So if we go back into that PCB directory, we're here. We're going to move the mini cap schematic and copy that right over the, we're going to just call this that, and we're going to remove this old file name. We're not going to use it. Welcome everybody that joins. We're doing some Topre PCB hacking with a XIAO footprint controller. So thanks for joining. Hit me up in the chat. Let me know how your Friday's going. My view count keeps jumping from 2 to 5 to 2, so I have no idea how many of you are there. We'll see how it goes. Okay. Pulling KiCad up again here. If we now pull up the schematic, now we're closer to what we're talking about here. Now, this particular schematic, I'm going to have to hack a few pieces out. This is a schematic for an onboard wireless Topre PCB. Obviously, we're not doing that. We're going to need to swap in a XIAO footprint controller. So we're going to have to hack out a little bit of things and then restore the things that we need from there. So for instance here, all this USB stuff, all of the ESD protection done. Don't need it. Similarly, we don't need a JTAG header for programming this. We don't need a user LED. The controllers offer them. We will have a reset button somewhere, so we're keeping that. We don't need a Bluetooth module. That's going away. So we'll get rid of this. Ditch some of these symbols here. Oh, nope. Yeah, this way. Get you out of here. We're going to save the reset button. Over here are a few test points as well as a bunch of the pin mappings for the other pages on our schematic. So we'll get into those here in a little bit. But starting with, we're going to need to get some local labels that correspond to our XIAO pins set up. Oh, I forgot about one pin I need. I might not be able to do our extra pin for the aid for shutting down our op amp. Here's why. I forgot about one piece of our design for everybody that just joined. I was doing my little review here of what pins I needed for what we've got going here, and I missed one core thing needed for a design like this, which is when you strobe one of your strobes. And you, where's our picture here that we were looking at? When you pick a certain column to be connected to your op amp, random street noise, and you strobe your strobe line to induce a certain voltage, there's basically stray voltage still from that spike on your analog input pin that you need to drain before you pick your next pin, your next location to read strobe and read a voltage. Because if you don't do that, there's still that voltage decay from strobing the previous one that will be lingering basically in the circuit, and you'll have to either drain it to get rid of it, or wait longer before you try and sample the next pin in your Topre PCB. So the strategy here, and there's a really good custom Topre design guide that was really, when I was first sort of reading up on this stuff, was a pretty nice review of everything. And it talks all about sort of the how long it takes for decay and this whole extra drain pin idea that lets you scan faster, basically. Now, if I skipped this, which I could, I'd need to scan much slower. And so here's where system design trade-offs go. What I think that we will say is that we don't want to have to scan slower. That would be bad. So what we could choose to do, we have a few options, none of which are great, but we have a few options here. Let's go back. Let's look at this, the XIAO BLE. Where's that pin out here? So the XIAO BLE has a few interesting things. In particular, on the bottom of the XIAO BLE, there are 2 extra pads, which are for the NFC pins. Now, normally, I'm not a fan of using these because using them breaks compatibility with other XIAO controllers, right? Like this Renesas-based controller that I have that inspired this project, it doesn't have NFC pins in the back. But if I choose to use the NFC pin only for that op-amp enable pin, and I leave the option via a jumper to either connect the op-amp enable to an NFC pad when you're building wireless, or when building wired, we solder close a jumper, which basically forces the op-amp to be enabled all the time. We can make it still work. Okay. Yeah, so there's our plan. We do need one more pin. We do. We need our drain pin, which is fine. We're going to steal an NFC pin for our op-amp enable pin when you're building wireless, because that's the only time when the op-amp enable pin really needs to be connected. I was worried there for a second, but there's hope. We can make it work. Okay. So, crisis averted. We carry on. Anyways, so I was saying, this is a really cool design guide. If anyone's getting into like Topre design, you want to like review the circuitry and understand how all the pieces work. Obviously, you can review a bunch of open source PCBs if you want to go that way. But if you really want to understand all the moving parts and why they're there, I really enjoyed this design guide that I found while I was searching. So we're okay here. There's hope. We need to do a little bit of cleanup here on our, to make sure we can pull in the XIAO symbol we're going to use. I need to find one that has those NFC pins listed. I normally don't use those. And so I will probably just create and like take my existing symbol and footprint and update them for this, which should be interesting. We'll do that. And so this, where did it go? Oh, we're also ditching this, by the way. I'll talk about that later. But this ADC enable pin, this is the one that's going to go to our NFC pin when we're building this wireless. But for other builds, we won't need it. Okay, so I'm going to kill all of these. We don't need them. And there's actually a whole sheet for this that we don't need. On my integrated wireless designs, there's an accelerometer that's used for waking. So like right now with my Zappy Bera that I'm typing on here, it'll go to sleep after a certain amount of time, like this, the ZMK timeout. And it goes into a deep sleep state. It's not scanning any of the switches because that burns a bunch of battery. And in order to wake it up, you literally move the keyboard and the accelerometer detects movement and it wakes up the device and now you're ready to type. But we're not going to do this. And so the strategy here when you build a wireless Reviung, I'm still going to have to learn to pronounce that, is it'll go to deep sleep when you're doing a wireless build. And when you want to wake it up, you're going to just hit the reset button. That's good, how it's going to work. So we don't need the accelerometer page. We're going to do that. Get rid of that. Can I delete it? No. This whole page we're going to delete. We don't need it. We're going to need the matrix. We're going to need the analog stuff. The power stuff we don't need. That's all related to the onboard power management when you're doing like an onboard wireless design. So we're going to ditch that as well. And so the things we're going to need to clean up a little bit to match our matrix are going to be this matrix setup, the actual matrix. Analog circuitry, we're going to use this analog circuitry pretty much as is. And so we've got these two muxes, one for the left side, one for the right side. We're going to keep those. We're going to need 6 channels, basically, from each. And then each gets its own dedicated enable pin. So all this is going to stay. We're using the op amp with this ADC enable. We're going to need to tweak this a little bit. put in that jumper and the optional sort of hook up to that NFC pin. That's all good. But the rest of this is all going to stay. So that's good. And then there's mounting holes. I'm going to ditch this for now because this was specific mounting holes for my others. Yeah. We're just going to delete it. Delete the mounting holes is actually what we're going to do because we're going to need a bunch of these holes for the plate assembly. So we're going to actually put a bunch of holes in there, but I don't want them messing with my design until I'm ready to do all that piece. So we're going to kill all of those. And now we need to get our XIAO symbol, our XIAO footprint, do some tweaks, do some pin selection, do some footprint swapping when we're ready, and then go from there. So we continue. Hit me in the chat if you have questions about the process here as I'm going. So here's what we're going to do. We've got our PCB here. I'm going to get, I have a design, the Rev XLP, which was the first design. That's not true. I did a Zaphod version with the XIAO controllers, but Rev XLP actually used more. So I've got this PCB, and I've got some symbols in here that I just need to remember where I put them. Is it all in? Oh, maybe I made copies of it. That would be lame. Yeah, okay, so see, do we know XIAO KiCad symbol? I think this is the KiCad symbol that I then modified and I've been using. So we're going to grab that, drop that in here, and then there's footprint stuff in here. And in particular, so I have this version that's called the wide mouth version, which is there for like one random controller. I don't care if we support or not. And so this is the footprint I'm going to want for this. So we're going to bring this one over. Just drop that here for now. We're going to need to make a folder for this. We're going to move that in there. This guy. And then I just like file names with spaces in them, so I'm going to clean this up. All right, now to do some KiCad bits to set these pieces up and get them in here. So, coming over here, preferences, manage symbol libraries, project specific. We already have it here. So we're going to add that one. Great. We're going to need to make some changes to it. We can do that once it's in. We're going to add our footprint library. And we're going to bring in a bunch of footprints from another project into that as well once it's set up here. So we've got this project-specific library. We're going to add this one here. Now we've got our footprint library. Great. So let's go into our symbol editor. And what do we got here? So I created this, see, do we know XIAO BLE? Yeah, so I had taken the original footprint that the Seed Studio folks had provided, which basically had sort of the original XIAO 4 extra pads on the back in it, and then all the usual pin designations, right? I made a BLE version that just basically pulled out only the reset and the battery plus pads. We're going to add a couple more pins to this and then make a footprint to match, update the footprint I have to match, to pull out the NFC pads that we care about. Okay. And so that's what we're going to do here. So like this, BIDA bidirectional pin. We'll take. We're going to duplicate it. We're going to put it up over here, sure, because it's pin 17. We're going to name it something different. NFC 1. It is bidirectional. And then pad 18 is going to be NFC 2. So there's going to be our symbol that we're going to use for our PCB. Hey, everybody who just joined, hacking on making a Topre version of the Reviung 41, but using the XIAO controller. If you're joined, hit me up, let me know how you're doing this Friday. So here we go. We've added a couple new pins to our symbol. We're going to bring this into our schematic, hook that up, and then we'll do some footprint work to tweak it. So coming back over here, coming into our schematic here, we're going to add our seed. Oh, I changed the B. Okay. I don't really love that. We're going to rename this while we're at it because it's really hybrid. It's not really for the BLE. We're going to say it's a hybrid for lack of a better term for it. And we're going to, oh, it was right there. We're going to add it here. Here's going to be our controller for things, right? So, for instance, nope, I don't want to add another one. Thank you. We're good there. Reset, that's going to go to a reset button that's on there. Easy. That's pretty simple. I am going to need a battery, like a JST socket for when we're building this wireless. I'll do that later. For now, we can leave that unconnected for now. We know that we're going to use one of these 0 through 5 as our analog input. From scanning here early on in the stream, we know that those are the analog pins across the selection, the wide variety of the various XIAO controllers. So let's imagine that we want to do the analog 0 here. So we'll call it a 0 just for expediency. And we're going to bring that over here. I already have these global labels that are picked up on my other pages of my schematic here, right? And so the ADC is going to be this A0. That's what we're using. Bring it over here. We're going to get rid of all these because these are all the old NRF 52840 pin assignments that we're not going to use. We have one less row we're going to need. So we can get rid of one of those here because we're going to have a total of 4 rows. And so the other pin assignments, we're going to have to see where those play out because the reality is we don't know for sure what's going to route the best to the different locations, okay? So coming over here, we're going to, I use that a lot often for my PCB designs. I'll defer some of my pin assignments, so I'll know which pins I don't really have any sort of wiggle room on, and I'll know which pins I do have some leeway. So for instance, when I'm doing NRF 52840 design, I know that only some pins are high frequency pins, and some pins can't go above 10 kilohertz or it affects the wireless performance. So I'll pick those pins early in my design. You know, if I'm doing some I2C or SPI bus stuff, right, I'll make sure those are on high speed pins, and the rest I'll just leave for later, right? So a couple of the things we know for sure that we're going to hook up. We're going to need our ground hooked up here. We know we're going to use our 3v3. We're going to use that pretty pervasively. I always struggle with this. I always want like nice design and everything in the right way, and inevitably like the ground being above the 3v3 makes me do this stupid stuff, so it looks weird. Anyway, so I'm pretty sure I used plus 3v3 pervasively here. Yep, so that's the right power symbol. That's going to provide off of the regulator or whatever on the XIAO the power for all of my analog circuitry, the op amps, the muxes, etc. So that's hooked up. We don't need the 5 volt. We're not doing any stuff right off of the like the USB or anything like that. So that's going to be disconnected. We need to tweak our footprint to be ready to do a bunch of nastiness. But first, let's look at our matrix. This is the matrix that happens to be from design I was playing with. little minivan thing. But we needed it to look like this. So we're going to fix up our matrix to match this design here. And so we've basically got a 12U PCB, and then we're going to be swapping this for two 1U keys. I'm not a big fan of the 2U in the middle for here. And so we've basically got 6 by 3 on one side, 6 by 3 on the other side, and then 6 across the bottom here. For this, this is going to roughly match what I already had over here. So if we take a look, we've got columns 0 through 5. And so here's our sort of like 6 by 3 for the left side. It's all square. It's all set. Same thing, I think, over here. And then you can see I was doing some funkiness because I happen to have some spare pins. We're going to clean up the bottom here a little bit. So this switch, for instance, can be moved over. That's going to live right there in the design. And we're going to bring some of these back. 41 here. This is named horribly, so we're going to do that. Clean this up. This is really, I don't want the value. This is really switch 42. So is the numbering actually right on all these? Up to 36. It's starting at 1. Fine. So then, yeah, I didn't think so. This should actually be 37, 38, 39, 40. Oh, you know, I can actually get KiCad to renumber these for me when I'm ready. So, I'll duplicate this. We're going here. I do need to fix that up so that that's connected properly to that row pin. That's there. We're going to come up. Oop, just kidding. All right, let's clean up a little bit of this junk that's not needed. This goes to ground, which is fine. We don't need it all the way over here. Similarly, we can clean that piece up. This isn't needed. There's no other switch there. Okay, so here is our analog matrix here. We've got our, and I can move this over here so we can see it. We've got our left and right side and our unibody split. Cool. We've got our bottom row. Again, I'm doing two 1U switches for the bottom here. That matches here. So that's the matrix we want. I'm going to get you to renumber these. Current sheet only. I want to go sort symbols by Y position first. I'm going to reset. Use first free number after 0. Yes. Annotate. Let's see to number them right. Why didn't you do it? I asked you to do it. Current sheet only. I'm going to reset the existing ones. Use first free number. Annotate. I said reset existing ones. Why didn't you do it? Why didn't you do it? Okay, fine, we'll do it manually. Thanks, KiCad. Okay. This is 37. This is going to be switch 38. Do. 42, yes. Okay. All right, so we're all set. We've got our matrix set up properly. These are numbered. Switch 31 through 42. If you look at the footprint listed here, this is a totally different footprint out of a library that we don't actually have set up here yet. So we need to fix this up here so we can actually access the write footprints, and we actually want to change the footprint assignments here as well. So before we go any further, we got to take a look. And I'm going to bring out of that mini cap, I have pretty. I could have sworn I had grabbed those footprints here. Let's find them. It was in the library here. Had that whole cap sensors up pretty directory. Yes. All right, so we don't necessarily need all of them in there, but I can clean that up here in a little bit. So we're going to manage our footprint libraries, add that new directory brought in. So good there. So now if we go back into our schematic, we're going to override the footprints for this stuff here. Nope, just kidding. I want to do this. What is not annotated? Oh, which part is not annotated? Oh, I didn't annotate this. I'm going to come back to that. Okay, so if we look at all of our switches here, there's just a couple here that have been set up with different sizes, and I don't want that. So we're going to make these all 1Us, because that's what we've got here. So this one, all going to be 1U, this one, all 1U, and these. All right, so now those all are properly the 1U footprints. Great. We're still going to need to, however, clean up this one here and get a footprint made for that before we can really start hacking away at the PCB here and getting into it. So coming back over into our footprint editor, we'd added those couple other paths to the symbols. So we're going to take a look at what we have so far. And so this is the footprint I have right now. And if we take a look at this, we can see we've got the standard pins numbered 1 through 14. So if we took a look at our symbol, you would see that those are the standard 1 through 14 pins. Cool in the gang, fine. We've got these 2 extra pins though, pin 15 and 16, which is the reset and the battery plus. Reset. The original XIAO had 4 pads on the back. It has reset. It has 2 SWD related pins, and and then 3 other. They're all like JTAG related for like using a hardware programmer for the original XIAO. But for most of the designs, I don't need to break out like the SWD pads. I'm not hooking up a hardware debugger to my keyboard most of the time, so I don't need it. But the reset button is the one exception that I do want. I want to be able to have a reset button broken out on the PCB somewhere else. So that gets 1 pad, and that actually I use on my designs a small pogo pin that's on the PCB that then pushes up against the pad here. Great. And then the last one here is the XIAO BLE. If you take a look at it, I still have that open here, has these 2 battery pins on the back. They've got a bat minus and a bat plus. This is handy if you're like soldering a battery directly to the XIAO BLE, but I'm not doing that. So I don't really need bat minus because it's just the ground. It's just another ground pin you could attach the battery ground to. But all I really care about is bringing out the battery plus pad with a pogo pin so that basically I can route my battery onto my PCB with a power switch instead of having people try and solder batteries directly to the XIAO. So that's there. We want to do the same pogo pin trick with our NFC pad here. We only need 1 of them here. In theory, you could do both, but the reality is this other one is going to be too close to whatever pin header you have, so it's going to be tight to fit there anyways. And so we're going to try and add yet another pogo pin for our NFC pad right over here somewhere. Now I got to figure out where. That's going to be the fun part. I'm gonna play something for now, and then I'm gonna dig up. I had found a like DXF file of like the physical layout of the XIAO BLE. I got to dig it up, see where I have it downloaded, see if I can rescue it and make it work here. So we're gonna add one more of these pogo bin pads, and it's gonna be somewhere over here, and it's gonna be for pin 17. And that's going to be the one that ultimately is going to be used for that NFC 1 pad that we're going to use. It's going to be hooked to the op-amp enable. So there's our modified footprint. Obviously, I got to clean this up before this gets produced or anything like that, but it's enough. We can get started here. So here's our footprint. Save the changes. This is our weird hybrid. I'm going to name this hybrid to match the naming for the symbol, so that it's there. Save it. I hit save. Save it. And now we're going to assign that here as well. And we're almost ready to do some PCB mucking around. Everyone following? Everyone here? Are you totally bored by this? Or are we having fun? This is going to be in the Topre Reviung. We're going to use this footprint. That's going to be good. Now, we're missing a bunch of connections again. That's fine. When we get a little bit closer to routing some of the stuff over to the controller area, we're going to see what shakes out of this. Okay? So, schematic's good enough. We're gonna really break our PCB here and see what happens here. So I'm curious the naming for the footprints already here. They did properly name this switch 1, switch 2, etc. This is good. So here's what we're gonna do. We're going to replace footprints with those specified. We're gonna relink footprints to schematic symbols based on the reference designators. Because I've done some serious hackery here to basically swap in a different schematic, we're going to need these two options, because otherwise it's going to really freak out, and like switch 1, that's this MX switch we're getting rid of, is not actually going to be tied to that switch 1 in our analog schematic, our Topre design. So we're going to do this, and we want to replace the footprints because we want to have our MX stuff go away. Now, this is an interesting option that in theory I will want to do, but I don't want to do it yet because that's going to be more destructive than I'm willing to do for this first pass of seeing what happens with this PCB update. So we're going to give it a shot here, see what all we break. Not too bad. Not too bad. It almost looks like this is did something right. So some interesting things here that happened here. So it has a bunch of our analog stuff. Cool. We're going to just, my usual strategy, drop it over here. Get it out of the way so we can think for a moment here. It dropped our controller sort of where the original controller was over here. Obviously, this used to use a Pro Micro. We're dropping in a XIAO instead, so things are a little bit different there. Our reset button is here. It swapped in our nice Topre pads pretty reasonably. They're rotated, most of them, the right way you would expect them to be. Now, we did get this random, what is this? Switch 39 is here. And I've got switch, what are you, 43 and 42 here, which is a little confusing to me. It looks like we lost switch 1 somewhere. Where did we lose switch 1 to? 41. It didn't relink one of these properly, because I've got to switch 40 and 41 here, and I've got 42, 43. Where did switch 1 go? So here's how we can do this. If you go over here and we pick switch 41 and come back to our PCB, it's calling this. Why did you do that? you say you're switch 2, but you've moved. This says it's switch 3. Did it relink them wrong? Because this is call 0 row 0, which is what you'd expect, but it's switch 2. Oh, why is this labeled switch 2? Okay, it numbered things wrong. Control Z, Control Z. Hang on. What's going on here? Why is this starting at 2? And this should be going to 42. What did it do? When I ran that annotate one more time, it totally mucked with things. Let's try this again, everybody. Reset, current sheet only, use for annotate. Why? Clear annotation. Why? Is there... here we go. This mucked with us. The annotations were global. And so because this was called switch 1 over here, it freaked out. We're going to call this RSW1, reset switch 1, and come back over here. We're going to try this again. Annotate again. Current sheet only. Free number after 0. Reset. Clear annotations. Annotate them. Switch 1. Thank you. Okay. That was a mess. That was a mess. So we're going to come over here. We're going to try this update again, but before we do so, we're going to fix this up. Oh, see, they called this reset 1. Easy enough to fix. That'll help us out. Okay. So now we're going to try this again. Same thing. We're relinking. We're replacing. Updating our PCB. It dropped all this new stuff and it just the one Topre pad, which is great because that's what we want because we're getting rid of this 2U here to add this other one. Yes. Okay. That's saner. That's what we wanted to see. All right. Okay. So we need to move this over. We're going to do an exact move. And we're going to move it half of a footprint's dimension. So negative 19.05 divided 2. Boom. That's great. We want to move. We're actually going to do this. What we're going to do, we're going to relabel this and then do that relink thing again. So we're going to make this one actually switch 41. This one is actually going to be switch 42. And that means this switch over here is actually switch 40. There we go. Okay, so we're going to move this, and we're going to be a little tricky here. We're going to move this from the center point, drop it on the center point of the other switch, and then we'll move it 19.05 over. Boom, it's here. Okay. We're getting there. We're getting there. We've got to do a little bit of cleanup before we start trying to figure out how we're going to squeeze all of our analog circuitry in. But we're making progress. So if we take a look, there's a few things going on here. This Reviung PCB, I'm seeing that they've got a few holes here now. These are probably mounting holes for like a sandwich, like case design, which if we take a look, yeah, you can see that they've got, that zoom didn't do what I wanted it to do. I just wanted the picture. Really can't zoom it. Annoying. You can see that there's some screws here that are almost certainly like through a switch plate to like a little threaded standoff to another base thing. So we're going to be doing a little bit differently there, but I don't really care about it all that much right now. But something we're going to need to clean up and figure out is going to be some of the mounting stuff. But we don't need it right now. For sure, there's some things we can get rid of. Like this LED, we're not doing. It's going away. It's getting nixed. The other thing that we're probably going to do is we're just going to blow away all of the traces right now, because we're going to reroute this whole thing. Right. And so if I remember, there's a way, I don't remember where that is. I saw recently somebody showed there's like a literally just like delete all the tracks. There was a tool somewhere that I'd never used before, that looked really handy, and I don't see it here. Could have sworn. Anybody that's on stream familiar with that? I saw somebody, they had like it was like a KiCad dog that was like delete all the traces. And that looked like really handy thing for what I'm doing right now, but I don't see it here. No, just pads. That's not what I want. Nor vias. Delete tracks connecting different nets. No, I don't want any of those things. I literally want to. I swear I saw somebody had that in a dialogue, and I was like, that would be handy for new designs. Yeah, no, it's none of this. I'm gonna have to dig for it later. We're just gonna do this manually by hand, but we're gonna clean up a bunch of the traces that we're not gonna use, and that's gonna help us sort of get to a baseline. So we're gonna dim any layer we're not on, and I'm going to. See, I really want to know what that was that they did for that. All right, fine. We're gonna just do a bunch of the usual manual cleanup, because I'm too lazy to Google it right now. None of these traces are going to be relevant to this. Just kidding. Don't do that. Gonna just. Is that a ground? Yeah. Okay. And we won't. I won't bother cleaning all this up. Oh, maybe I will just get it out of here. We know. We are hacking away at this. This is annoying. I'm going to Google it. I can't handle it. Global delete in the edit menu, says somebody. Anybody see global delete? Hey, this was the dialogue that somebody had showed me. This is the one I wanted. There's 3 of you hanging on still. Okay, delete items. We're going to delete all of the tracks and vias. Unlock tracks, unlock footprints, vias, all layers. Yes. Yeah, that's what I wanted to do. All right, it's got a zone fill, whatever. We're going to zone fill. So here's the next thing we are probably going to need to do. The real question will be, can I get away with doing this as a 2-layer design? In theory, yes, but it won't be as nice as doing it 4-layer and really isolating things. So I think that I'm going to stick with what I know, which is going to switch this to a 4-layer stack up before we do anything else here. We're going to add some layers here. And so It's been a while since I set one of these up from, yeah, here we go. That's what we wanted to do. 4 layers here. Board thickness 1.6, yes. So now we're going to have our front copper, back copper, and our 2 inner copper layers. We'll have that available. That's going to be squared away and ready. We'll do a fill for one of those with our 3.3 volts, and then we'll leave the other 2 sides as just ground pours, which is fine. I don't want to switch back here. We're getting there. So for instance, I'm going to get rid of some of this silk stuff because it is not at all relevant to what we're doing here. We'll move our controller into place, start getting our analog stuff roughly where we want it. This is going to be our controller here, which is great. Now, probably before getting this made, I will like tweak this edge cut design. There's some advantage to sticking with the normal Reviung edge cuts, but it leaves the controller sort of like sticking out more than it needs to. You know, we could scoot it over and clean this up a little bit, but not a big deal. We'll leave it for now. But so here's the new controller location. We're going to have these pads for the various functionality for things like the op-amp connections. Our analog pin that we picked for our ADC pin is over here. That maybe is a reasonable choice, but we might want to actually have this, like this 5th pin be our analog, so it can connect sort of uninterrupted over to what's probably going to be most of the core analog circuitry right in the middle here. That's my guess where we're going to end up here. So here's what we've got. We've got all this stuff here. One of the questions is going to be, do we want to put our analog circuitry front side or back side? We for sure, since ideally this is a cheaper build you can do with Topre, ideally this is something you can do single-sided assembly at JLC to do this. So we're going to do a few things. We're going to continue to clean up stuff that we don't need. It's not going to be QMK powered, so I'm going to ditch that. We've got a bunch of these diodes from the original work we don't need. So here's the question. I'm going to save this. We're going to do this potentially destructive, which is delete footprints with no symbols here. And see what happens. So it deleted all of our mounting holes. I was a little worried about that. I don't know that I want to do that yet. Because if we wanted compatibility with like existing case stuff easily without having to redo this, I might want to keep these locations of things. So we might need to play a little bit. So I'm not going to do that delete. I'm just going to find all these darn diodes and nuke them individually, which is fine. There's not that many of them. Get rid of the underglow here. Now, there's a few other things we're going to want to do at some point before we route all of our like Topre footprints, which is for column stagger designs like this one. You'll notice that the normal footprint here has these, assuming that the switches are sort of normal row stagger, but that puts the like markers for where the screws would go, well, either screws and or standoffs or whatever for the plate assembly in the wrong spot. And so there's another footprint that has the things rotated a little bit, which is the one that we are going to use here instead, so that that's just can help us visualize things there better and easier. All right, nuke a few more things. still have 4 of you in theory here. How's it going? Is this boring as all get out? My stream of consciousness on how I approach random weird Topre work when I get a random bug to make a XIAO Topre thing? Or have all of you stepped away from your computers and I am talking to myself, screaming into the void? I'm going to go with the screaming into the void option here. Or it's Friday and none of you really planned on joining a stream, and you've maybe out of pity left your computer on with this window open. Nope, not what I wanted to grab. You. Almost done with the cleanup. We'll start placing our muxes and op amp and all that stuff here in a second. All right, so we've cleaned up, gotten rid of all those silly diodes we no longer need. Gotten rid of some of the silk there. So here's what we've got. We've got our 2 muxes. We've got our various resistors for the various bits here. We've got our op amp here that includes the output, the power it's getting, our ADC that's going to actually feed from our op amp into the ADC input on our controller. We've got some test pads just for if we really needed to scope this and figure out what's going on. And so first thing we're going to do is we're going to figure out roughly where we want to get our 2 muxes in place in a reasonable spot here. You can see that this mux is tied to this side. We can easily see that with our rat nest here. So this one's going to be over on this side. And so I've been thinking about front or back side assembly. We got a few options here. So if we're doing JLC assembly, one of the things that I like to do for like the mounting for cases for easy tray mount is solder nuts on the bottom side of these designs, which makes it easy to literally just like attach a plate to the bottom to your solder nuts and you're done. And so if I want to be able to support that sort of a plate design, I can have JLC assemble those solder nuts too. So bottom side could be some benefit. I'm going to have to hand solder some of this because JLC is not going to solder this thing anyway. So the reality is it might be nice to have it be hand solderable. So I might as well do bottom side for these. And so we're going to put these on the bottom here, and that's where we're going to place stuff. It'll keep the top, in theory, just a little bit cleaner and nicer and not risk getting bumped by stuff. And I'll have more room because I'm not fighting like the housings by these switches here, right? So we're going to assume mux here. Other mux coming over here. This mounting hole is very quickly going to annoy me with this sort of usable space in the middle here. And so I might ditch it, but we might be able to get away with putting everything just above it and not having issues. And so, for instance, most of the columns are on the other side here. That's not universally true. I could, if I wanted to, use A6 and A7 instead, which are pins 2 and 4. So these pins 2 and 4 could be column pins instead. Not really that useful to do that. And so I'm going to rotate this because we're going to want our output from this, the thing that's connected to to be able to easily route to the interior here and into our op amp. So we're going to put that here. Similarly, the aplex out is here so that we can get both these here and up to our op amp circuitry. We're going to put pretty much in the middle here. Oh, thank you, spammer. One of my 4 viewers is a spammer. You go away. I don't like you. I don't usually have to moderate my chat here. Just go away. Goodbye. Well, okay. So for however of you who are left who aren't spammers, hopefully you're enjoying. This is our op amp here. This is the thing that's going to amplify the spikes coming from our analog circuitry. So this thing here is going to be the thing that's going to get us a voltage we can read more easily here. In theory, I might want this closer, and so I might move this up along with these two so that that is closer here. This will probably work. So now I just need to get the various resistors for my lines spaced where I need them, and then all of this circuitry here. So for instance, I need C2, R7, R8, and R9 are going to be over by my op amp over here. So R7, R8, and R9, I'm going to bring over. Where'd you go? R7, 8, 9. Are coming over here. They're going to be tied to our op amp. We're going to fix those up in a second. C2 and C3 we're going to bring over here. C2 and C3 we're going to bring over. No, why did you grab other stuff? Ah. Yes. Okay, so these are going to need to be by our op amp as well. That's squared away there. We're going to get those better placed here in a second. Our test pads, I'm not that worried about right now. If we take a look, we're going to need each of the muxes gets a decoupling cap by it. So C1 is going to be on the left, C4 on the right. So C4 was for this right. We're going to put this decoupling cap nice and close here. There. C1. Is going to be the decoupling cap for the power here. Fine. Now, the resistors that are left. So, the resistors here on all of our various strobe lines help bias those lines and help control the decay so that basically any capacitance from any other switches pressed nearby don't affect the sampling of this switch that much. So each of our read lines gets a resistor attached to it. Those don't really matter where they go per se. I usually try and put them sort of the middle of the particular column or whatever. So that's the rest of the resistors that we're talking about here. We got our decoupling caps. We've got a decoupling cap here going into our op amp, and then this main capacitor for our analog circuitry, which is needed there as well. And then the resistors here are used for adjustment. So that's what we're looking at. And so we can find spots for those other resistors. So for instance, I'm looking for resistor 1 through 6 are going to be on the left-hand side here. So we can grab resistors 1 through 6. I didn't snag anything extra I didn't need. Great. These are going to come over on this side. Then these other 6 are going to be over here on this side. Flip those over. We're getting there. Those resistors, it doesn't really matter where they are. They're not as interesting in terms of the routing and the design here. So we're kind of getting there. So for instance, let's take a look. We need to get some of this stuff for our op amp figured out here. So our pin 6 needs C2, that decoupling cap there. If we do this and do our bottom, it'll be kind of easier to see. Nope. I want you next to pin 6. So that's going to be our decoupling cap. So the question will be, we might need to rotate our op amp to make this a little bit nicer to route. The enable pin and our ADC are going to be related to our controller. So I'm going to, in theory, decoupling cap here. We can route our ADC enable pin up and out. We can route our ADC pin up, keep it nice and clean and away from stuff, and coming up and over here to one of our ADC pins on our XIAO controller. Aplex out, that's coming from our muxes. So that's going to get routed nice, cleanly straight down and over to those two. Cool. And then we've got the various other circuitry here for this op amp to do its thing with these extra resistors. So those are tied to pin 1 and 4. Pin 1, our ADC pin, and pin 4 here. So that we can probably route maybe down and through and get to where we need it to, and it'll work. It'll do what we want it to. I think that's the ticket here. So I need to bring resistors 7, 8, and 9 over there. I don't like this dim. It's just bothering me as much as the busy that is the other stuff going on here is bothering me just as much. So 7 is going to be coming over here. 8 and 9 are going to be working over here. And then my main cap, which is tied to here, I'm going to actually bring this down. It's going to live right over here for the extra capacitance for the circuitry here. So in theory, there's a small additional capacitance from our somewhat longer traces here, but it's fine. And so I've got to get this all routed. So if we take a look at here, I've got a set of these that are all coming and tied to the ADC, and then one that's tied to ground. And so it doesn't really matter which. The R9 actually gets a do not place on it. It's there for adjustment if you need it for tuning the circuitry. So it's really 7 and 8 that we're mostly worried about. And so for instance, if I put my 7 there, my tuning one in theory, this can go here, actually, and 8, which is our do not place. Is that right? Sorry, no, it's our 9 that it's our do not place for tuning. I'm going to actually tweak that a little bit. So this can stay here. Yeah, and that's our do not place. Okay, so we're going to do that a little bit differently. We're going to do these here and here. That's going to be for our ADC here. And it's going to route through and to this. That's fine. And this one here is going to be here, and that's going to just be to ground there. ADC is going to go here. Just, no. Spin you around. You there, and then our ADC pin will come and get routed up over here to one of these ADC pins. We might change our minds on which one. So then the other things that we care about, the ADC enable pin is also going to come up and over. And the reality is I'll probably route it to one of these other pins up there. And then the aplex out is going to be coming down, straight down here, and then get routed and routed. So basically, one of these muxes will be enabled at a given time. And when it is, it's going to connect one of our columns to this aplex out, which will then route the column through the mux to the aplex out. A little extra capacitor there. Aplex out goes into the op amp. The op amp will amplify whatever parasitic voltage spike occurs. That the amplified signal comes out of the op amp and to this ADC pin out, and over here where it's going to be connected to one of the analog inputs on our XIAO controller. So there's your analog circuitry and how that's all going to jive, and that's going to happen. Now, we might end up picking different pins from our muxes depending on how the routing actually sort of works out here. But there's a few other things we can do in the meantime to clean this up. We got to get power to our various components. So we're going to add in this inner copper layer here a 3.3 volt fill, which is going to make that all easier. So we're going to place a ground fill here. It's going to be on this layer. It's going to be our plus. Okay, so I have a plus 3.3 volt and I have a plus 3V3. This is where I check my schematic and see what I did here. Plus 3V3, plus 3V3, plus 3V3. Did I do that wrong here? I did. Yes. Okay. Just kidding. Try that again. All right, update from our schematic. We're not doing that one. Okay, that will make that a little bit cleaner. So when we go to add our fill now, just the one net, it's going to be this layer. It's going to be solid. We're going to stick with all the normal settings for now. And we're going to do a giant fill here on that layer. So that's going to just make it so that this inner copper layer here is got my 3v3 easily. And so when we do that, you can see that for these plated through holes, that inner copper layer here is going to be directly connected to that plated through hole only on that layer. So I don't really need to do anything to route out my 3v3 because it's just going to this one inner copper layer that's the whole PCB, because I added my fill, not a ground fill, a fill here, 3v3 fill, that I now can use to easily get power to all my other components. So if we take a look here, this view is just killing me here. I don't know what's up with KiCad. I think I updated versions. And the display here is absolutely horrible for seeing here. But if we take a look here, we're going to route here. The second we drop this via here, and I do a new fill, we'll see that the via through the decoupling cap for the power here, right? This via is going to be separated from my top fill, right? Because the top is a ground. But if we take a look at this inner copper layer, it is fully filling and connected to my via. So I'm easily getting nice solid, 3.3 volts in this one layer for whatever my various components need power easily. So it's making routing all of that way easier, having this fourth layer for the power layer totally separate from all the other stuff. So that's easy now for getting power to my various things that need power. That's my op amp, and my muxes here are going to need power as well. So if you take a look here, same idea. That's there. I don't need to route it from there. It's just going to get to the fill. I've got my other power pin. Oh, I'm over by one. Over here to my filled layer. I redo my ground fills, redo my fills, and now I've got power to my 2 muxes, power to my op amp from my 3v3 layer, middle layer going on here. So we're getting there on this. You can see that the grounds are automatically connected here because I have my ground fill on my upper and lower layers. That makes that easy. Similarly, my ground pins here are good. Obviously, for a sensitive analog circuitry, we're probably going to do a bunch of stitching vias everywhere just to make sure that there's no funky return paths on anything from the components anywhere to the controller. As we add routing and tracings, we'll need to make sure that that's clean. But we're getting there. We're getting there on our design so far. And so here's the next fun thing here. We need to get all of our strobe lines figured out for pulsing a given row. We've got to route our read lines from our columns into our muxes. Add these few additional resistors here, those bias resistors for the analog circuitry, and we're feeling pretty good on some test points. So it's starting to almost look like a design here. If we take a look at what the PCB looks like at this point. Oh, I didn't want you to rotate. I just want you to come over here. So at this point, obviously, there's some of this mounting hole stuff we're going to probably want to tweak. But this is what it's looking like so far in terms of the design here and what's left to do. And so if we take a look at the back here, fairly simple in terms of the circuitry because we've offloaded a bunch of the more nitpicky design things to the XIAO controller we're going to be dropping on here. The reset button they have on the bottom here, I probably will change that. But there's our 2 muxes. There's our op amp that's going to be amplifying signals, and that's going to eventually go into our analog pin here. And we're getting there. We're getting there. Time check, 9:12. We're doing okay. I probably got another 15 or so minutes before I'll call it for the night. But we're getting there. I do want to clean this up. Like these should be vertically centered. Clean that up a little bit. I want to get rid of these labels here, which are on the original design, but I don't think are necessary for this. So before we do anything else, saving this, I did want to try and take a look at the footprints here. I had made that note about where to go? So there's this ECPad 1U footprint. Oh, that's the CAPI pad. This is this 1U footprint, and you can see the sort of rendering of the switch housing is here. And it's fine, but I'd really like it to properly visualize the locations for me when I've got this in a column stagger setup. You'll notice if you look at the CAPI pad 1 does it that way too. I'm probably obsessing. Yeah, here, for example, you can see this CAPI pad 1U 90-degree rotated. This has it so that when you rotate it, the capybara is right, and the switch is going to be aligned the way you would expect it to be. So we're going to try that. We're going to do the same thing. We're going to take our ECPad 1U, and I actually want to tweak this just a little bit. So I'm going to make a copy of this. We're going to duplicate it. We're going to call it, we're going to rename this 90 degree. And it exists where? ECPad 1U 90 degree. I don't see that. I see CappyPad. There's no 1U. Then why aren't you showing it to me? It's there, but it wasn't. Okay, fine. It already exists. So we don't need to do this. Delete this. Yes. I wanted to delete that. Yes. Okay, just kidding. I just need to swap the footprint. Great. So coming back to... okay. Why was that rotating furiously? Okay, coming back over here, going into the footprint assignment here. If we take a look at all these, we're going to change all of these to that rotated here that I missed at first. That's not strictly true. I'm going to probably switch all of them, and then I'll need to switch a couple of them back that are along the bottom. Yeah, so in particular, switch 39 and 40. I don't think I want to do that for. And honestly, most of that bottom row, I probably don't want to do that for. All right, let's do this. We don't need to relink anymore. We are going to replace the footprints here. And so when we get here, now we'll see that if we rotate all of these, which is what we'll end up doing, now the Topre pad portion is the way we want it to be, and it's properly if it would let me pick the right footprint here. I love KiCad, and then there's other days where I don't love it. Do. All right, get these all the orientation we want. And we can see for this bottom row, we're going to leave this as is. And I don't want to see the fills anymore because that's annoying. So this is the way, because we're going to have our mounting screws, our plate screws for this column stagger, EC design are going to be in these locations here and here, right? And so now we can just properly visualize it and see it, and it all makes sense. And then this bottom row here is more sort of like a row stagger bottom row here. And so these screws will leave, and we'll use the non-rotated versions of these for this. So that'll do that. That's what we wanted. I did want to clean this up and actually just put this at the same height as this one because that's bothering me that it's not. Okay, now they're actually level with each other. That's better. Okay. Anybody still with me? How we doing? All right. This should look closer to what we were going for. Actually looks the same, but the visualization helps me out. So we're sticking with it. I hate the green. Not wasting any time with it. Okay, so we need to figure out our columns and bring them down to my muxes. And then we need to get our rows for strobing brought up and in to the controller area. And we're going to need to, at that point, sometime pretty soon here, decide on what we want to have where for our pin usage here. So we're going to have to make some hard calls there. My suspicion is that we will use strobes from these four here and bring them out and down for the strobe lines. And the pins over here we'll use for the mux control, only because the mux controls were going to be done once and then left. And then in theory, they're more static and it doesn't matter as much if they are nearby to our ADC pin that's going to do the sampling. Yeah, so we're getting there. I got about 10 more minutes in me. Since I'm only going to stream for another 10 minutes, if anybody has any questions on any of this process, Topre stuff, design stuff, hit me now, because I got to go before too much longer here. So let's see. We need to get our columns routed to our muxes. Why are these so off? Why are you saying column? Okay. Column 0, column 6, column 0. Why are we off by 1 here? Column 0, 1, 2, 3, 4, 5. Column 6, 7, 8, 9, 10, 11. As you would expect, switches 1, 2, 3, 4, 5, 6. So what is going on? I've got switch 1, 2, column 0, column 2, 3, 4, 5. That's all. Why is this not column 0? Switch. All right. So yeah, we're getting there. We're getting there. I just realized that the original Reviung had numbered the switches a little bit weird. And so when I updated from my schematic, it did not do what I expected. In particular, my expectation is that when you get to here that this is switch 7, but the original Reviung put switch 7 here, which is just giving me some headaches here because I was seeing that for some reason I had column 0 here, column 1 as expected, but then this was column 6. And the source of my frustration and pain right now is the fact that their numbering is really funky in the Reviung and not what I expected it to be. Yeah. So what I'm going to need to do to fix this up so that it will let me route this and it won't be total crazy pants here, is I'm going to need to, for instance, take this and I'm going to need this to properly be switch 6 here. Thanks. Hey. Oh. Let's see. Let me see if I can clean that up in OBS and dial back the music. Dial up me a bit. Is that any better? No worries. I'm definitely not a pro streamer, so let me know that sort of stuff, so that I can fix it. Yeah, cool. Okay, so what's going on here is we're going to need to clean up our references on all of these and then update. And so if we take a look, for instance, like this is properly switch 1, 2, 3, 4, 5, 6. This needs to be switch 7, not switch 19. And so when I clean these all up, this is going to be 8. Yeah, exactly. They numbered a whole side. They did like 1, 2, 3, 4, 5, 6, 7 here and numbered the whole side. And that's, I don't know. I would never do the references that way by side. I would literally just do the whole row, right? And so for my sanity's sake, because updating the schematic is going to be a major pain, I'm not going to do that. I'm just going to fix up the references. And then when I do a update from schematic, I'll do that whole relink footprints action. And that's going to help massively here. So that's 10. That's 11. That's 12. This is 13. Nope. Did I do that right? Nope. I thought I was off by one. Uh, 13, 14, 15, 16. Yes. This is now actually 19. Uh-huh. 19, 20, 21, 22. Yes. 23. So this is 25, not 13. 26. 27. 28. 29. Nope. The whole switch. Please. Oh, is it finally right? 31, 30. Yes. Yes, finally right. But not. 31 should be. Oh, yes, column 6. That is correct. Okay, so now, sorry, why do the references need shifting? Yes, I mean in theory they're fine, but it won't let me route them properly because the nets are assigned wrong. So you can see that like this column of stuff here, this says this switch, this half of the footprint is going to column 6, but this is going to column 0. So until I fix this, Kaika's not going to let me route these in a single column because the nets are assigned wrong to the footprints. And the easiest way for me to fix up the nets is to actually have the references updated to match my schematic, so that when I go to route this, the nets will be assigned correctly to those footprints, right? So Now I can relink these footprints to the schematic symbols based on their designators, and it will do the right thing. So as soon as I update this, we can see that now my column, the nets are properly assigned to my footprints based on the schematic, so that these are all actually in the same column, right? Without that, I would have been fighting when doing the routing the whole time. That's the issue. That's why I needed to fix it up and clean it up. Yes. So that's that. So now, for instance, I can actually get this column routed the way I want it to be to these columns here, for instance. Now, I have been fighting this. If anybody is on here, KiCad does not like, and I'm going to actually rotate this footprint to make this routing easier. Why does it? Nope. See, this is what I don't like. KiCad has been really fighting me with some of these Topre footprints. It really dislikes the pads that get created for the cap touch, like the cap footprints, and it won't let me nicely route it unless I do some serious funkiness to force it to basically route this the right way. And you can even see it's fighting me, and that's leading to and it's not a huge deal. It wouldn't have any substantial effect on the PCB, but fundamentally it's not letting me route this the way I would want to for this. And so there's a few tricks I can do. The main one, which I dislike doing, but is the most effective, is the brute force select everything, rotate, and then rotate around the local coordinates origin always, so that your rotation doesn't shift things you don't want it to. And rotate it, I believe the Reviung's a 13 degree. Yes, but I rotated it the wrong way. We're going to rotate it a negative 13 degrees. And now, oh no, it was not 13 degrees. Let's take a look. How many degrees are you rotated? Oh, where is the rotation information? I could have sworn this included the rotation information when I looked at the footprint properties. It doesn't do that? Oh, rotation 100. So it's 10 degrees. Aha, okay. So select everything. I'm going to do a rotation. I'm going to do negative 10 degrees around the local coordinates origin. Boom. Now, when I go to do my routing, and I will actually delete these traces that I did because they are funky. Now when I go to do my routing, I'm basically routing things in a nice sort of 90-degree frame of reference for this half of the keyboard. For unibody splits like this, it's a trick that I've used fairly frequently to make it nicer to route things. And so now I can route this out because KiCad is grumpy over, and then if I can convince it, get it to let me route like this for my routing here. And if it'll let me clean it up, annoying. But so you can see by doing this, I can avoid some of KiCad's grumpiness with these Topre footprints, and it'll let me basically route into the edge of this pad and then to its connection point. The reality is this entire pad is connected. I don't need to do anything else from a from an actual physical connection perspective, but KiCad thinks I do. It thinks that this is the connection point. But by doing this, I can have my quote unquote trace hiding here that's just swallowed by the giant pad that's part of the footprint, but it still lets it be routed properly. And the like nitpicker in me doesn't want that extra piece of the trace at an angle coming into these footprint centers. So that's going to let us actually route and connect these in a way that does not offend my sensibilities as deeply as it might otherwise. And there's always a little bit of this cleanup needed, but it lets me get a nice sane trace coming out of the pads on these EC footprints that is not as painful. And I certainly, to a certain degree, don't need to be this picky about it, but I sometimes am. So this is going to let us route our columns. Oh, I see this got rotated that way. For consistency's sake, I will do this. Okay, there we go. Yeah, you can see KiCad has a tendency to want to jump that funky angle trace where I don't want it, unless I trick it to do otherwise. There we go. Okay. So we're going to do the same trick here. Fix up some rotations here. Getting there. I'm going to probably need to call it here in a few minutes. But what I'll probably do is I will keep going on this probably this weekend. Nope. And then see how close I can get to a no, I just want, sometimes KiCad makes me angry. See how close I can get to this being a fully routed PCB by the end of the weekend. The interesting thing is going to be trying to see if JLC in fact has the op amp that I like using that has the shutdown pin in stock or not. If not, that will complicate things for getting prototypes of this made. So we might need to play a little bit with component selection if I need to pick a different op amp, which I will hopefully not have to do. All right, we're getting there. See if I can get just the last little bit of this side routed. Come on, KiCad. Don't fight me too much now. You there. Of course, you're grumpy. There you go. All right. All right. So we've got most of our column connections here set. And so what I can do is I'm going to switch to the other side and get the traces pulled out for routing the rows. And actually, I will probably actually route it most of the way over and then go from there. So for instance, my row here, if I'm coming up and around, is probably going to end up being a little step row here until I get over to the other side as well. So that's going to be my row connection here. That's there. So now the whole row gets strobed together. And so this is where I realized that I may have wanted to swap which layers I used for my row strobes instead. Yeah, okay. So I'm going to call it because I'm pretty toast from being on for 2 hours and I need a break. But I'm realizing I needed a little bit more advanced planning based on the side I'd selected for my components for like my op amp and my muxes here. And in particular, I've got these row lines. These are going to be the lines that are strobed coming off of my controller, right? And so the reality is I don't want those on the layer with my component because they have to cross because the whole row crosses both sides of my unibody split here. And so I really want those on the opposite side. I want those on the front side, and my column connections are actually going to be on the back side because they're going to get routed anyways to the muxes on the back side. So I'm tired, of course. I missed that. So I'll go back and redo it. But so fundamentally, the plan here is I'm going to get my rows, my strobe lines onto my front side, get those basically crossing the whole width of my PCB. I'm going to get my column lines back onto my backside, backside of the PCB, so that I can then route them to my two muxes. So each of my columns from this side, including these 3 footprints here, are going to get to my right mux. Similarly, I've got all of my columns on my left side. Obviously, I'm going to rotate it 20 degrees the other way to do that work. We'll get routed to this mux so that the mux selection coming from the controller will do the right selection stuff and do that. So here's the big picture on what's left. I got to route all the matrix lines. I need to add my resistors that are related to the analog circuitry. And then I've got to do the final routing of my actual pins from my controller to a few spots. I've got to pick an analog pin, settle on that. I've got to route my mux control pins, both the 3 address, sort of the selection lines, plus my enable lines, because I only enable one side or the other at a time. And then I got to get my drain pin set up to my circuitry to properly drain the circuitry when I am in between sampling. And then do that sort of op amp enable pin magic so that when we are doing a wireless build, we can turn off the op amp when we go into deep sleep so that we're not draining a bunch of power for an op amp that's not being needed because we're not doing any scanning. So those are next steps. I don't know if I'll stream them or not. As fun as this is, it's also mentally taxing instead of being focused on the work here. But this is going to be the plan now, obviously. So that's just PCB design. I'll need to find the right JLC parts so that I know I've got the right part selection when we go to get this assembled. I'll need to do adding all of my mounting holes for the plate assembly. Topre plate assemblies, obviously, we need to be able to secure the plate assembly with all the stuff there.